Hey, this is Dino, and I want to talk today about Envoy Proxy, and then later we'll talk about the Apigee Adapter for Envoy and how this all works. So, what is Envoy? Envoy is an open source project. It's a layer 7 and layer 3 4 proxy that is designed for assisting in service oriented architectures. Um, Similar, I think it was originally conceived as a replacement for Nginx and HA Proxy. The originator of this proxy, Matt Klein, formerly of Lyft, designed it to support the distributed systems that he was working on. It's since become a widely supported and adopted open source project. The code is on GitHub. It's implemented in C++. The build is with Basel. So you can go and build it yourself. Most people don't. Most people use the official built Docker image for Envoy. In other words, they run Envoy within a Docker image just by referencing the Envoy image URL. But you can also run it, build it and run it on any platform you like, whatever makes sense for you. So layer 3, layer 4, you can use Envoy to proxy TCP, HTTP, gRPC, lots of different protocols, database protocols, and so on. Today, I'm not going to cover all of it, but just a brief introduction, particularly using Envoy as a reverse proxy for HTTP. So we'll look at the documentation here, life of a request. First, some terminology. There's a couple of things that a couple of terms you'll hear me use through the rest of this screencast. Cluster. Downstream is a thing that connects into Envoy. It contrasts with upstream, which is a thing that Envoy connects to when forwarding a request for a service. There are listeners, so maybe similar to, parallel to virtual hosts. These are things that Envoy listens on. That'll include ports. There's an idea of a filter and a chain of those things that is essentially a request processing pipeline. So the network topology often for Envoy is used as it's set up as a sidecar, which means there's a single Envoy proxy associated to each service that's running in the network. And when this is containerized, these are just running in pods that are related, and all the requests that go into a service, like service A, first go into the sidecar proxy, Envoy, and then Envoy will proxy it into service A if it approves. The Envoy sidecar can do things like authorization checks, rate limiting, health checks, and so on. Likewise, if service A wants to communicate with service B, it does so through Envoy proxy. So it communicates first to its Envoy, and then that Envoy connects to the other one. So Envoy is used for ingress communication to services and egress communication from services to verify things like, we don't want a service to just be able to contact anything, any endpoint, anywhere on the network. So often used as a sidecar, but it's used in a variety of configurations beyond service mesh. For example, just as an internal load balancer, you've got a bunch of different services, maybe they're in different clouds. You can use Envoy to load balance among them and do health checks. You can set up Envoy as an ingress-egress proxy on the network edge for all services. In practice, a lot of times it'll be a hybrid or a combination of all these things. So Envoy as an ingress proxy at the edge of the network, Envoy as a sidecar, Envoy as an egress, Envoy as a load balancer. So lots of different things, and they might be used in combination. They can also be used in multiple tiers in more complicated scenarios. So this is software that you run and operate on your own VMs. And the high-level architecture is a request comes in, it reaches a listener the listener has some filters that are configured, may do things like verify keys or perform rate limits. And then, if all those filters succeed, the Envoy will forward the request to some endpoint that's running in a cluster that's configured in Envoy. So a set of endpoints. So let's switch over. That's a brief overview. Let's switch over and see it work. First, I'm going to show you some configuration. This is what an Envoy configuration file looks like. It's defined in YAML. This one uses dynamic configuration for listeners and clusters. So I'll show you the listener first. So this just says, how do I want to listen? I'm going to tell Envoy to listen on the local host port 10,000. And then I've got some filters set up to handle the inbound HTTP requests. So some logging to standard out, and then I've got routes configured. So for every request that matches, for any domain that matches, that has a slash as the first part of the path, we're going to route to a cluster called cloud. That cluster is not defined here. It's just referenced. And so that's pretty simple. Basically, this is going to match every request, and it's going to just proxy that to some other endpoint that's defined elsewhere. So very simple. Envoy's not doing much here, just acting as a reverse proxy. So if we want to look into the cluster definition, this one is showing a couple of different clusters. Here's the one called cloud, and really it's just an endpoint that's located elsewhere on the network. This happens to be an echo service, and it's telling Envoy, well, use that as your target. And then we've got some TLS configuration, sort of standard stuff for HTTP proxies. So all requests, according to the listener definition that I showed you, will be forwarded to this cloud endpoint. So let's see it working. I'm going to start up Envoy. I'm going to point it to this dynamic configuration. It's going to read the listener and the cluster definitions, and you'll see it start up. After Envoy starts, we'll be able to invoke those endpoints. But in the meantime, let me show you the cloud endpoint. This is that same endpoint. It's open. It's listening at that DNS address, and really it's just sending back a JSON payload that provides some information about the inbound request it received. So it tells us the URL was /. If I append something here, we'll get a different response. It'll say, hey, the URL you passed was foo. The method was get. These are the headers we received inbound. There was no query. There was no body. So in the case of a post, it would reflect that back as well. So that's the echo endpoint. And what we've done is we've started up an Envoy that is listening at port 10,000 local and is forwarding to those to that echo endpoint. So let's see that working. That's here. So at this point, I'll just refresh this, and you can see I'm invoking localhost 10,000 and getting back the same response from that same endpoint. So in fact, my echo endpoint that's running in the cloud is still receiving the request, but it is going through Envoy at this point. So Envoy acting as a basic reverse proxy, and you can see some of the logging here. That's what it's doing. And if I do this a lot of, lots and lots of times, you'll just see lots and lots of different response payloads for that. So that's the basic operation. We can also do things like modify this to include additional cluster. So at this point, what I've done is I've added in 2 clusters. So previously it always routed to the cluster named cloud. Now I'm routing to one of two different endpoints, and these can be weighted as indicated here. Right now they have equal weights. So Envoy is doing the same thing, except now the upstream has two potential endpoints, and in the cluster definition, you'll see this ngrok endpoint is accessible via a different DNS name. So it's the same echo service. It's just running at a different DNS name. Very equivalent to the cloud service that I showed. Let's try. So I can invoke that directly here. You can see, basically the same payload, except the host name is always this thing, because that's where the service is located. And now if I invoke it from Envoy, what we should see is Envoy will spread load to both of those endpoints according to that configuration, that listener configuration that I showed you. So sometimes when I invoke port 10,000, I'm going to that cloud endpoint. And sometimes when I invoke it, it's going to that ngrok endpoint. They are equivalent services. That's what Envoy is designed to do. And you can set up weights and load balance on different inbound parameters, parts of the request, and so on, all according to that filter definition inside the listener configuration. So that's an example of multiple clusters. So now what I'm going to do is update the configuration again. And now what you'll see is I've added a rate limiting configuration for Envoy. So Envoy's got a number of different configuration options, and it's all in YAML. You kind of have to dive into YAML if you want to use Envoy directly. All this is, the schema for the YAML is defined and documented. You do have to wade through some documentation, but basically what this is saying is apply a local rate limit. When it says local rate limit, that is local to the Envoy process. So if I've got a single Envoy, it can enforce a rate limit. If I've got multiple different Envoys that are running in a farm, in that case, a local rate limit will not be ideal. You can still use a local rate limit if you sort of apply the law of large numbers, and if you expect load to be evenly distributed across those envoys, then let's say you have 3 of them, you can apply your rate limit at 1/3 the target level, but you still have some hysteresis there. So there's a local rate limit possibility in Envoy. There's also a distributed rate limit, which requires that you run your own Redis service, and then all the different envoys will connect to Redis and collect their rate limits there. But in this scenario, I'm just showing the local rate limit. I have a single process, and basically it's the leaky bucket algorithm that has, the bucket size is 10, and it gets refilled every 20 seconds with 10 new tokens. So basically that's saying you're going to have a rate limit of 10 requests every 20 seconds. And then there's also some headers that get sent back on the request, so that we can see what the rate limit status is. So if I do, let's see, if I turn on a repeated call to curl at port 10,000. We should be able to see the response coming back, and you'll see the rate limit headers being sent by Envoy. The limit is 10, the remaining is 2. It's resetting in 4 seconds. Okay, so now we've hit the rate limit. You can see Envoy sending back 429 calls. We're still sending these requests. So this will get a 200 for a while, and then and it'll start going 429 until the bucket refill every 20 seconds. So this is an example of local rate limiting that you can enforce in Envoy. Static rate limiting. In my case, it's rate limiting just every request is the same. It is possible to specify how how the rate limited is enforced, maybe distinguishing on a particular header value, and so on. So lots of flexibility in there. You kind of have to read the documentation on Envoy in order to understand the possibilities there. So let's continue moving on. I'll stop that request. I want to move to the next listener configuration, which is the number 4. And what did we add here? Here we added an additional route for path hello. Previously all requests were being sent to these clusters. In this case, I can have sort of a loop back from within Envoy, a direct response, and it'll just send a 404 not found if I invoke it with the hello path. So flipping over here, maybe I'll do curl, and that'll get an actual response from one of the clusters. Whereas if I append the hello path, at this point I should get a 404 not found with my string, and it's coming directly back from Envoy. You can see the rate limit is still applied in those cases, in the direct response case. So that rate limit filter is still happening, even though I'm fulfilling the call directly from the Envoy proxy itself. So that's another item that you can do. I'm just kind of giving you a tour here of some of the different features, and I think maybe we want to move to number 5, the configuration number 5, which is, what have I done here? I have changed the weight. So you can now see I've changed the weight for the cloud to be 5 versus 1. So 5-to-1 requests should be honored by that cloud system. So if I go over to this page and sort of hit this again, repeated results, we should see a 5-to-1 ratio, and it's not going to be exact, but you can now see this host name is almost always that cloud endpoint, and every once in a while it's the ngrok endpoint. I'm still getting the rate limit, so if I click a lot of times, that rate limit is still enforced. So that's all interesting stuff. That's just Envoy Proxy. So what the Apigee Adapter is some configuration that we apply to the Envoy Proxy. It looks like this. Apigee adds some filters to the listener chain to do authentication and check API keys, and also evaluate Apigee rules like rate limits and API product authorization. So in this case, what I've done is removed the local rate limit that's done by Envoy, and we're sort of using the Apigee rate limit that's going to be enforced by the API product. In order to allow this, you need to have an API product set up in the Apigee side, and you need to connect the Envoy to your Apigee organization. So here's an example of my Apigee organization, and it's got a proxy there to handle remote token, and there's a remote service proxy there that's set up for the Envoy adapter. This is all documented in this documentation page. How to get started is all there. It talks about running Envoy in Docker and how to get the configuration, and also how to run Envoy natively, separately, not inside a Kubernetes cluster, and this is what I'm doing. So relatively easy to set this up. But once the architecture for this requires that you have a remote service running, a remote service that the Envoy adapter will connect to, and that's going to run on port 5000. If we go over to the configuration, you'll see in here the remote service is defined here in, let's see, where's the cluster? Right here, Apigee auth service. So that's going to be a new cluster that is defined that describes how to connect to Apigee, and that Apigee auth service is here, and you can see it's on my Apigee endpoint. There's also an Apigee remote service, which is at port 5000. That's the thing that I was showing you earlier. So two different endpoints in the cluster definition that the Envoy adapter relies on. And those all work to allow Envoy to enforce Apigee rules. So I've started up the remote service locally. My Envoy is still running. I'm going to update the cluster definition and also the listener definition with the Apigee Envoy settings. And at this point, Envoy now knows how to handle requests and authorize them according to the Apigee product rules. So if I, let's see, let me flip over to, let me bring this other screen in. I'll flip over to my my Apigee organization, and you'll see I've got in my proxies, I've got a remote service and remote token. These were configured for the Envoy adapter. These are just regular proxies, sort of helper proxies that the Envoy adapter uses. Nothing really elaborate here, but these things will collect product information and send it down to the Envoy remote service and issue tokens and validate things and so on. I do need to have a product defined, and we still use the product, the developer app, and the credential in the same way. In this case, we need to have an operation defined on the API product, and that operation needs to have a remote service, and that remote service is the Envoy endpoint. In other words, the thing that Envoy is listening on. So in my case, it's going to be, I've configured it to port 10,000 on localhost. That means that the rules that I've set up here, this get on any path is allowed under this product, will be enforced by Envoy. I also need an app that is enabled for that that Envoy adapter. So here's that product that I showed you, and we need that key because we're gonna send in requests now, and Envoy is going to validate configure the authorization. So let me search back. So we'll try it with just here's the API key that I just grabbed. We'll try it without the key on 10,000. And what we should expect to see is a 403 forbidden. Now this used to work. Envoy is still receiving that request, but now clients are receiving a 403 forbidden, and that's by definition because I'm not sending the required authorization anymore. So if I want, I can send X API key with the API key, and we expect that to work. So Envoy is now validating the API key that the client sent in before proxying to that upstream cloud service. And I can continue to do this, and it will be balanced according to the weights in the cluster that I showed you earlier. The rate limit, though, is defined by the API product. In my case, the API product does not have, I didn't specify a rate limit. So, it's going to run, it's not going to be limited based on the rate. Okay, so what did I show you? I showed you Envoy Proxy, And some basics there, the open source project, you can build it, you can use it as a Docker image. I built it and used that for my examples. I talked about the basics of a request and how that's handled. I showed you Envoy Adapter. I showed you Envoy Proxying to upstream systems without any Apigee integration, and some of the different things that you can do there just by fiddling around with YAML. And then I added in the Apigee Adapter for Envoy, which is really just, it's a combination of extending Envoy's configuration with different filters for authentication, and also a filter for handling the the API product-based authorization via the external authorization filter, and connecting into that remote service that's running locally on my machine. So those pieces together allow you to build a hybrid, lightweight API management capability using Envoy Proxy, running that anywhere in your network. That is convenient for you, usually on some optimized path between the client, the requester of a service, and the upstream of a service. So you can use this Envoy adapter when Envoy is configured as a load balancer, when Envoy is configured as an ingress proxy, or when Envoy is configured as a sidecar. Any of those configurations that I showed you earlier will work with the Apigee Envoy adapter. So nice basis for basic API management capability. The adapter does not enforce arbitrary Apigee policies. So you'll notice that I'm not configuring an Apigee proxy with all the instructions for what to do. Instead, it's really just this filter that is doing the Apigee things inside Envoy. And this filter does just a couple of things. It's API product authorization and rate limiting. That is to say, with the operation and the method, the path and the method in that operation definition inside Apigee, and also the rate limit for the same. So, when we have this remote service and that path and this method, then it's going to be allowed. But if we send something else, it'll be disallowed according to the API product authorization. So that's all that Apigee rules can do. Also, analytics gets sent to Apigee. That's not configured here. That's separately. But those are really the three things that you get with the Envoy adapter. You don't get XML to JSON policies. You don't get SAML. You don't get all the arbitrary policies that you get within the Apigee Enterprise Gateway. So that's it. That's the summary. I hope this has been helpful and informative. Till next time, keep it digital.